Hello everyone, we continue studying Tact. The topic of today's lesson is inheritance. We will look at the possibilities in Tact for inheriting our smart contracts and on polymorphism. So let's get started right away. We'll begin by discussing the first form of inheritance we have used throughout this course, inheritance from the deployable. In Tact, contracts can inherit from each other, so we use another entity called a trait. In the case of a deployable, we take this trait from the library, but now let's write it ourselves. We'll need the trait deployable and two messages it will use. Message deploy with query ID and deploy OK with query ID. The deployable trait consists of only one receive method, which is to receive the deploy message. Upon receiving this message, it signals that the smart contract is deployed. All it does is send a response message, specifically a deploy OK message. Next, let's look at the Ownable trait. I'll create a new contract for this, and in all examples I'll use a counter. The Ownable trait also exists in the library, and we can get it as follows. And after, our Ownable counter contract can inherit from a trait Ownable. After we inherit, we need to create a variable called owner of type address and initialize it in our init method to indicate who exactly is the owner. And now we have access to a method called requireOwner. And after this, our receive will only accept messages from the owner's wallet. But just to be clear, let's write the Ownable trait ourselves. We also need to pass a variable here, but we won't initialize it here. It'll be initialized directly in the contract. Next, we'll only need two methods. The first is requireOwner, which we use here. There'll only be one check called native throw unless. This takes an error code as the first argument, which it will throw. The second argument, it takes a condition. In our case, we say here that if our sender equals self-owner, the code can proceed. Otherwise, an error will be thrown. The second method in the Ownable trait is a getter function that returns our owner. I believe everything is clear about a contract inheriting from a trait, and Tact also supports multiply inheritance. However, there are also other traits in our library, which we have commented out for now. One of them is the Ownable transferable trait, which not only allows setting the owner, but also changing the current owner to another one. It works like this. We write the Ownable transferable trait. It inherits from the Ownable trait and also needs to declare the owner variable. However, all other methods are implemented by default. Now we will add a new receive for changing our owner. We will need the change owner message for this. Let's create it. It'll have only one field, new owner. Here we must specify that only the current owner can change the owner. After this, we can change the owner. I want to note that when developing your own contracts, it's preferable to use the Ownable transferable trait. First, it gives you more flexibility in managing ownership. Second, if your contract provides for decentralization in the future, meaning at some point your owner may no longer be necessary to maintain the operation of this DAO that operates on your smart contracts, you can change the owner to a zero address. In this way, you will remove the owner and no one will be able to control the DAO. Okay, another trait that exists in the library is Stoppable and Resumable. Let's take a look at them now. To get this trait, we need to refer to the same library, but let's immediately write it ourselves. For the stoppable trait, we'll need our ownable again. Let's import it from the library this time. The stoppable trait is designed to stop our smart contract in case something is not going as planned. In our case, with the counter, we will stop our receive for increasing our count. Naturally, only the owner of the contract should have the right to stop it. For this, we again specify the owner variable here, and also we have a stop flag of type bool. To stop the contract, we will use the stop textual message. Let's make a check here that only the owner can do this. Then we change our stop flag to true. Actually, a good practice in such messages is to make reply functions that will report if the result was successful or not. Finally, we want to receive a notification that our transaction was successful. Also, in the stoppable trait, there are two functions called require not stopped and require stopped. That's it, our trait functionality is ready. Let's also add a getter for the stop flag here. Now, when inheriting from our stoppable trait, all we need to do here is add this stop flag. By default, we will have a natural value of false, and now we can add the next require for add message. Yeah, we still need to specify the owner. And our stoppable trait is ready, but there is also another trait in the library that extends stoppable. It inherits from stoppable and only implements one function, resume. That is, to resume our contract back to work. We write require owner and also require stopped. So in case the contract is stopped, this code will be executed. And then we change the stop flag to false. After changing the flag, we make a reply function that our contract has been resumed. Okay, let's now write our own trait, not those that exist in the libraries. I'll call it trackable. I want to make a trackable trait that will count how many messages were sent in total to the smart contract. That is not the current count value, just the number of messages that have ever been received. I declare my trait. Here I will have a variable num messages received. And so far only one method that will be called receive new message. Now I need to duplicate the num messages received variable in my counter contract and initialize it in the init method. Okay, now to use it, I just refer to my contract self and the receive new message method, which will increment my incoming message count. Naturally, I'll need a message here. Now I want to demonstrate to you the ability to work with virtual and abstract methods, using trackable as an example. I'll need ownable trait here. I'll fetch it from the library. Now I'm going to extend our trackable. I'll add the ability to reset our statistic. There will centrally be a require owner check. Only owner can reset, and reset the num messages received. And let's say I want to change my receive new message method so that the statistics of new message will be only from other users. That is, messages from the owner are not counted in these statistics. For this, I'll now create a virtual function that I'll call filter message. It will return a boolean value for me, and here I just check if my sender is equal to owner. Then I return false. If it's not sender, if it's not owner, then the return true. And now my receive new message will only work with those messages that have passed the filter. But what if I want to filter my messages differently in another contract? Or if such a trackable trait is in the library and other developers don't want to filter messages like that? That's why is virtual keyword is used, to be able to override the logic of this function. To do this, we go to our final trackable counter contract and we can rewrite this function using the override keyword. Thus, by rewriting the function inside the trackable counter contract, it will behave differently within the trackable trait. In other words, I have now cancelled my filtering at all, and it will always return true for me, no matter who the messages come from, whether from the owner or other users. And I did it in the contract that inherits. And so we have already touched on how polymorphism works in Takt. Continuing this topic, in Takt you can override not only functions, but also constants. The fact is that constants in Takt are more advanced than in more programming languages, and we can also declare them as virtual or abstract. The difference between a virtual constant and an abstract one is that we can initialize an abstract one only in the contract that we will inherit. Now we are going to declare a virtual constant, which we'll name enable reset. It will be of type bool, and the default value will be true. We will use this variable in the following way. We will use it to indicate if the given contract can reset statistics. And in order to disable the possibility of resetting statistics in any contract that will inherit trackable, we will need to declare this constant inside the contract with the keyword override and set the value to false. And the Takt compiler is smart enough to understand that in the case where we specified the value false to our constant enable reset, as this is a constant, we will never reach this part of the code, and this code will never even make into our Takt compiler. That is, this code will physically not exist in our contract because we have specified the value false for the constant. The method reset stats will of course exist, but in this specific example it will be empty. The compiler will only skip this part of the code. Let me just check here that everything will compile. Yes, I did not specify the owner variable here because our contract is inherited from Ownable trait, and naturally we need to specify it here as well. Great, that's all. The lesson has come to end. I would like to say that our next video will be about creating your own token on the Ton blockchain. Although in Ton terms it's called a Jeton. I know how many of you are waiting for this video, so I'm happy to announce that it's coming soon. We will fully cover this standard, write our own contracts, and figure out how it all works. So see you in the next lesson.